Hello and welcome. In this video, we're going to take a look at solutions to the homework for Unit 5, Lesson 5 on quadratic formula. Now, to do quadratic formula, you need to remember that we are only substituting into this equation right here. We have to substitute for a term that is identified as b 2 times, a 2 times, and c only once. So we have to substitute for these terms, these numbers, a, b, and c. You also need to remember that your quadratic needs to be written in standard form, which means ax squared plus bx plus c equals 0, where a is the term in front of x squared, b is the term in front of x, and c is the trailing term. For number 1, we're going to solve this quadratic 2 ways. First way we're going to do is we're going to factor it. So again, for both methods, we're going to identify a, b, and c. A is 1, b is -4, and c is -12. Again, please remember to pause or rewind the video as necessary. If we're going to factor this, let's start by making our cross. A times c goes on the top, b goes on the bottom. Well, a times c would be 1 times -12, which is -12. b is -4, so we put -4 down here. Now you need two numbers that multiply to give you -12 and add to give you 4. So I'm thinking of my factors of -12. Well, that would be -12 and 1, or 12 and -1. Or it would be -6 and 2, or 6 times -2. Or it would be -4 times 3, or 4 times -3. These are my 6 possibilities that would multiply to give me -12. Out of all of these, the only one that would add to -4 would be -6 and +2. And I'll just slap on an x in front of these, and there's my factor, ladies and gentlemen. X minus 6 times x plus 2. And yes, it's equal to 0. Now, to solve this, we're going to use the zero product property, which I abbreviate ZPP, zero product property, which states that if two numbers multiplied, a times b, are multiplied together and they equal 0, then a has to equal 0 or b has to equal 0. So what I do is I set each term, x minus 6 equals 0, or x plus 2 equals 0. Add 6, subtract 2, and our solutions are 6 and -2. Now, let's solve the same quadratic by quadratic formula. So we're going to plug our a, b, and c into that equation right there. Let's do this. X is equal to, now negative is always part of the formula, so automatically write that down, negative. But b is also -2, so negative times a -4, plus or minus. The square root of b, now b would be -4 squared minus 4 times 1 times -12, all over 2 times 1. Now we just clean it up a bit. I can clean this up 3 ways. Multiply this through, and combine these. So negative times a -4 would be +4, plus or minus. The square root of, the first term would be 16. Minus a minus becomes a plus. And 4 times 1 times 12 is 48. All over 2 times 1, which is 2. Next step, go ahead and take care of that. When you add 16 and 48, we get x is equal to 4 plus or minus the square root of let's see, 16 plus 48 is 64. And that's divided by 2. Well, that's the same thing as 4 plus or minus 8. Square root of 64 is 8 divided by 2. And at this point, we can go ahead and write our answer as two solutions. So x is equal to 4 plus 8 divided by 2, or x is equal to 4 minus 8 divided by 2. So that would be 12 over 2, which is 6. And this would be negative 4 over 2, which is negative 2. And you'll notice, ladies and gentlemen, those are the same two solutions, two different methods. Number 2, we're going to solve this quadratic using two ways. First way we're going to do is completing the squares. Second way is quadratic formula. So still need to identify a, b's, and c's. So a is 1, b is 6, c is 3. Now, when we do completing the square, we're going to write down the trinomial, but we're going to create distance between the first two terms and the third term. So this becomes x squared plus 6x plus leave some space, and then plus 3 equals 0. Why do we leave some space? Well, we're going to add in that space a term that is b over 2 squared. Now, b term is 6. So 6 divided by 2 is 3. Square 3, we get 9. So we're going to be adding 9 to this term here. But if we add 9, we have to balance that by subtracting 9 as well, because 9 minus 9 is 0. And if you're adding 0, you're not really adding much of anything. You're not changing the value of the function. The next step we're going to do is we're going to section off these three terms, and then we'll go ahead and add those terms together. So the first terms here that I have highlighted in blue, that's your perfect square binomial of x plus 3. Negative 9 plus 3 would be minus 6 equals 0. Add 6 to both sides. And we get x plus 3 quantity squared equals 6. Square root both sides, plus or minus. And we get x plus 3 equals the square root of 6. Go ahead and subtract 3 to both sides. And x is equal to negative 3 plus or minus radical 6. Using quadratic formula, x is equal to, x is equal to negative b plus or minus the square root of 4, the square root of b squared minus 4ac all over 2 times a. Now, your b term is 6, so we're going to go negative 6 plus or minus the square root of 6 squared minus 4 is part of the equation. A is 1 times c is 3. All over 2 times a is 1 on the bottom. This would be negative 6 plus or minus the square root of 6 squared is 36 minus 4 times 1 times 3 is 12. All over 2 times 1 is 2. Add that part together. Negative 6 plus or minus the square root of 24 all over 2. Now, the square root of 24, we can break that down. The largest perfect square that divides into 24 would be 4. So this would be the same thing as negative 6 plus or minus the square root of 4 times 6 over 2. which is negative 6 plus or minus the square root of 4 times the square root of 6 over 2. Simply split those up into their own radicals. Then take the square root of negative 4. Take the square root of 4. So x is equal to negative 6 plus or minus 2 radical 6 over 2. At this point, we're going to take the 2 and we're going to split it up as two separate denominators under the first term and under the second term. Here's what I mean. The first term is 6, negative 6, so negative 6 divided by our 2 plus or minus 2 radical 6, also divided by our 2. Now, it cancels from the second term, but it reduces the first term. And we get negative 3 plus or minus radical 6, which again, same solution. Number 3, we're going to solve that quadratic by factoring and by quadratic formula. Now, when we're trying to factor something that has a coefficient of 2 in the front, you know it's going to factor like this. If it were x squared, it would factor as x and x would be the first terms. So if it's 2x squared, you know it's going to factor 2x and x, because 2x times x has to multiply to give you 2x squared. So that's the first part. You know how the beginning part's going to be. The final part, the second term, has to multiply to 20. So let's think about our factors of 20. What are our factors of 20? Well, they'd be 1 in 20, 1 times 20, or negative 1 times negative 20. They would be 2 times 10, or negative 2 times negative 10. They would be 4 times 5, or negative 4 times negative 5. Right? And those are the only factors that multiply to give you positive 20. So what I do is I do a little trial and error, and I multiply the inner and outer terms and see what will give me negative 13x. So if I try, let's say we tried, I don't know, the 2 and the 10. Let's say that. Now, since I have a negative 13, I'm going to try the negative side over here. So negative 2, negative 10. What if I try the negative 2 here and the negative 10? Well, no, that's not going to do it because my inner terms are negative 2x. My outer terms are 20x, and that's negative 22x. That's too large. So that's not it. I could put the 10 over here and the 2 over here. And in that case, I have my inner terms are negative 10x, and my outer terms are negative 14, negative 4, so that's negative 14x. And it's close, but no. What if we tried the 4 and the 5? So if I put a 5, let's see, if I put a 4 here and a 5 here, that's 4x. Negative 4x minus negative 4x minus negative 10x is 14x. Nope, that doesn't work yet. Okay, I could break it down. Let me try the other way. What if I put the 5 over here? Let me see, I've got 5x and 8x. There we go, negative 13x. Okay, so negative 5x minus negative 8x is negative 13x. So that's going to be how it factors. And so we have 2x minus 5 times x minus 4 equals 0. Use the ZPP. Use the zero product property, which tells you set each term equal to 0 and solve. So 2x minus 5 equals 0, or x minus 4 equals 0. Add 5. 2x equals 5. Divide by 2. One solution would be 5 halves. 4 is the other solution. Okay, by quadratic formula, A is 2, so A is 2, B is negative 13, and C is 20. So here we go. Quadratic formula, negative B, so x equals negative times negative 13 plus or minus the square root of b squared, so negative 13 squared, minus 4 is part of the formula, times a, which is 2, times c, which is 20. All over 2 times a, which is 2. So we have, let's see, negative is positive 13 plus or minus. The square root of 13 squared is 169 minus 8 times 20 is 160. All of that is over 4. That's the same thing as 13 plus or minus the square root of 9 over 4, which is the same thing as 13 plus or minus 3 over 4. So those are our two possibilities. We have 13 plus 3 over 4, which is 16 over 4, which is 4. Or we have x equals 13 minus 3 over 4, which is 10 over 4, which reduces to 5 over 2. Again, same solutions. Number 4, if the quadratic formula is used to solve this function here, the correct roots are. So we have to use quadratic formula to solve that. So a is going to be 1, b is going to be negative 4, and c is going to be negative 41. Okay, so quadratic formula, x equals negative b, so negative times negative 4, plus or minus the square root of negative 4 squared, b squared, minus 4 times a, which is 1, times c, which is negative 41, all over 2 times 1. Well, that's going to clean up as 4 plus or minus the square root of 16. Now, minus a minus becomes a plus. So 16 plus 4 times 1 times 41 is 164, all over 2. Well, that's 4 plus or minus the square root of 180 over 2, which is 4 plus or minus the square root of 36 times 5 over 2. Break this up and pull out the square root of 36, which is 6. And so we have x is equal to 4 plus or minus 6 radical 5 over 2. But split up the 2 into both parts. And 4 divided by 2 is 2, plus or minus. That reduces to 3 radical 5. Which would be part 2. All right, in question number 5, we're not only given a function, but we're given the graph of that function too. The function is f of x is equal to x squared minus 12x plus 31. And we're given the corresponding function over here, the graph of it. Part A, find the zeros of this function in simplest radical form. So, simplest radical form, what does zeros mean? It means find the x-intercepts. So we need to set y equal to 0 and solve for x. X squared minus 12x plus 31 equals 0. Using the quadratic equation, so a equals 1, b equals negative 12, c equals 31. Plug it into the quadratic formula and evaluate. Let's do this. X equals negative b, but b is already negative 12, so negative times a negative 12, plus or minus the square root of b squared, so negative 12 squared, minus 4 times 1, which is a, times 31, which is c, all over 2 times a, which is 2 times 1. Let's clean this up. Negative times negative is a positive 12, plus or minus the square root of negative 12 squared is 144, minus 4 times 1 times 31 is 124, all over 2. Subtract those parts there. And we have 12 plus or minus the square root of 20 over 2. Now 20, the largest perfect square that goes into 20 would be 4. So we'll split this up into 12 plus or minus the square root of 4 times 5. We'll split 20 up into 4 times 5 over 2. 12 plus or minus 2 radical 5, because we split that up, take the square root of 4, which is 2, over 2. And then lastly, we're going to split up this into 2 different fractions. So it's going to be 12 over 2 plus or minus 2 radical 5 over 2. This reduces. 2 goes into 2 once, 2 goes into 12 6 times, and that reduces to 1. And we get x is equal to 6 plus or minus square root of 5. Part B, write this function in vertex form by completing the square. Based on this, what are the coordinates of its turning point? Verify on the graph. Well, in order to do this, we need to complete the square on this. So y is equal to, or f of x is equal to x squared minus 12x plus 31. Take the first 2 terms and separate them. So x squared minus 12x plus, leave some space, plus 31. What goes here, of course, is b over 2 squared. The b is negative 12, so half of negative 12 is negative 6. Square negative 6, we are adding 36. But we must subtract 36 as well. Section that off. Y is now equal to your perfect square binomial, x minus 6. Minus 5. This is the coordinates of your vertex. 6 is h. 5, negative 5, that's really the same thing as plus a minus 5. So your vertex is at 6, negative 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Indeed, the vertex is at 6, negative 5. And in number 6, it says the flow of oil in a pipe in gallons per hour can be modeled using the function f of t is equal to negative 2t squared plus 20t plus 11 equals 0. Using your calculator, graph the function on the axes below. Let's see how to enter this function of the flow rate of oil into our graphing calculator. While I realize many of you do not have a graphing calculator in front of you at the moment, follow along with me so you can see how it should be entered. You're going to press your y equals button, and you're going to enter in the function for the flow rate of the oil in the pipe. Make sure you hit the negative sign at the bottom under the 3, not the minus sign next to the 6. Negative 2. Instead of t, we're going to put x squared plus 20x plus 11. Now, the next thing you're going to do is you're going to go to your Windows button right next to y equals. And we can hit enter on this. Open up your window, and we're going to change the scale. If you look on the graph, the scale only goes from 0 on the x-axis to 15. So my minimum is still 0. My maximum is 15. And it looks to me like we can create a scale. We can go by 1s. That's fine. We can go by 5s. It honestly doesn't matter. I'll keep it going by 1s. Same thing with this right here. Y min is 0. Y max looks to be about 75. We can have a scale that goes by 1s, 5s, 10s. It honestly doesn't matter. Now we're going to hit graph. And there's our function. We can see if we're going by 5s, we can see that the initial point is just a hair above 10, which makes sense because the function ends in plus 11. So 11 actually represents, 11 gallons per hour actually represents the initial flow rate before anything starts to change with regards to hours in the function. Anyway, your graph for part 6 should look like this. So as we saw from the image on the graphing calculator, we have somewhere around here 11, that's the initial point of flow rate, gallons per hour. And if we look on the image of the graphing calculator, if you rewind to that part of the video, you'll see that when we go on the scale, we go by ones, okay, and we're going from 0 to 15, and you end up with zero gallons per hour at, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, between 10 and 11. So if I section this off at 5, 10, somewhere between 10 and 11, we expect the function to come back down. So the function itself rises really high, like this, and then comes back down to that point right between 10 and 11, something like that. Use the quadratic formula to find to the nearest tenth of an hour the time it takes the flow to stop. In other words, come to 0. So find its zeros. What do we do to find its zeros? Set f of x equal to 0 and solve for t this time, not x. Solve for t. So what is quadratic formula? Let's write it above. Instead of x, it would be t equals negative b plus or minus square root of b squared minus 4ac all over 2 times a. If you look at our original function, a is negative 2, b is 20, c is 11. Plug those into quadratic formula, and let's figure out the time it takes for the flow rate to stop or come to 0. So t equals negative 20 plus or minus the square root of b squared, so that would be 20 squared, minus 4 times a times c. So 4 times negative 2 is a, 11 is c. All over 2 times a, which is 2 times negative 2. We have negative 20 plus or minus the square root of 20 squared, which is 400. Now minus a minus is a plus. Well, 4 times 2 is 8, times 11 would be 88. So 400 plus 88, all over 2 times negative 2, which would be negative 4 on the bottom. So t is equal to 20 plus or minus the square root of 488 over negative 4. Now, we would evaluate this 20 plus or minus. The square root of 488 is about 22.1. So evaluate this part right here. We get about 22.1 over negative 4, and we'll split this up into 2 different responses. So we have negative 20 plus 22.1 over negative 4, or t is equal to negative 20 minus 22.1 over negative 4. Well, in the first one, we add these, we get a plus, divided by a negative number, we actually get negative 0.525 seconds. That's not going to work because time can't be negative. Here we get two negatives that make the number more negative divided by a negative equals a positive. In fact, we get 10.5 seconds, which makes a lot of sense because it's halfway between 10 and 11 seconds. So that answer makes a lot of sense. Use the process of completing the square to write f of t in vertex form. So let's write f of t. It's negative 2t squared plus 20t plus 11. Now, to write it in vertex form, you need to separate this and factor out the leading coefficient. So you need to do two things. So I'm going to factor out the leading coefficient of negative 2, and I have t squared plus, now if I factor out a negative 2 here, if we look at the prime factorization of negative 2t squared plus 20t, I hope you guys realize that that's the same as negative 2 times t plus 20 breaks down into 2 times 2 times 5 times t. If you look what's in common to both, what I'm going to do is I'm going to pull out a negative 2. So, well, how can I pull out a negative 2 from here? Well, that's easy. You pull out a negative 2, it just changes the sign. And that's what I'm going to end up doing. I'm going to pull out a negative 2, and you can see what's left. If I pull out a negative 2, I'm left with t squared, not plus, but minus 10t plus, I'm going to leave some space because I'm going to complete the square. Okay, and then I'm going to write my plus 11 way over here, okay? What goes in that third spot? Ladies and gentlemen, again, it's b over 2 squared. So my b term is negative 10, so let's go negative 10, take half of it, that's negative 5. Square that, we get 25. But here's the catch. I'm going to be subtracting from that. I'm adding 25 here, so I'm going to subtract from it 25 times the negative 2 that I factored out. So rewriting this, we get f of t is equal to negative 2. My perfect square binomial would be t minus 5 squared. That's going to be a plus. So negative 25 times negative 2 is plus 50 plus 11. So our function is negative 2 times t minus 5 quantity squared plus 61. My vertex, my maximum flow rate is at 61 gallons per hour. It's that right there. It's the K. Here's my H. Here's my K. Here's my H. And if I look, sure enough, right here, that would be about 61. So 61 is the maximum gallons per hour flow rate of oil. And the time it takes this happens in t equals 5 hours. In other words, 5 hours is the time it takes to get to the maximum.